Okay, more science for G-Man today. Osmosis. Now, what is osmosis? Well, osmosis is it's the movement of water across a semi-permeable. That means that it lets some things through but not others. It's all about the size of the molecule. Water is small enough to get through, but things like glucose are too big. So it's semi-permeable membrane from an area of high water concentration to area of low water concentration. Let's just keep that in mind. I'm going to highlight something. So we're looking at from high water to low water. It's the movement of water. Always about the movement of water. All you got to remember is that we're looking at how water moves. Now, where does osmosis occur? Osmosis occurs in our cells. So we draw ourselves a couple of very simplified cells, and there's a cell, and we've got a little nucleus in each of these cells, and this here will be the cell membrane. And it's the cell membrane, the bit that forms the sort of bag that encloses the cell. It's this, which is our semi-permeable membrane. When we're thinking of osmosis, we're thinking about how water moves from cell to cell, or from outside of cells into cells. I'll just draw on a few mitochondria in each of our cells. So looking at these cells, you ought to be able to guess by now that they're animal cells. Well, okay, so let's imagine we could zoom into this part here. So we're going to draw our cell membrane as if it's semi-permeable. And by being semi-permeable, what we're doing is we're putting little gaps in, and these are gaps which are big enough for water to pass through. But yeah, I'll use this pen. Okay. So they're big enough for water. Okay, and remember, we're thinking about high water concentration. So what do we mean by water concentration? Well, think of it like this. If we've got 10 water molecules, well, if we've got 10 molecules. We've got 1, 2, 3, 4, 5, 6. And we had a different kind of molecule in there. 7 molecules, 8, 9, 10, and these are on either side of our semi-permeable membrane. Remember, around, it's as if we've just zoomed into this bit. And on the other side we have another 10 molecules. We can see on this side there's more water. That's a higher water concentration. Now the water in this, because what we're talking about is it's a solution on either side. Okay, so we've got our osmosis. We're thinking about how water moves. Oops. Across our cell membrane, our semi-permeable membrane. And what I've just done here is showed how you got a higher water concentration here than here. But one of the things that we might have to worry about is the word solution. Now, the thing about a solution is that if you've got a solvent, which in our case is the water, and you have something dissolved in it, that is the solute, equals a solution. And when we're talking about the concentration of solutions, we're always talking about the amount of solute in it. Okay, so our solvent is water. Let's pretend this is glucose. Our solute equals a glucose solution. So now in our diagram we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a 10% concentration. On that side, and a 30% concentrated solution on that side. So hopefully you're seeing how all of this fits together. We're thinking about osmosis. Remember, the movement of water. We've got this idea that inside our cells we have water. Inside our cell here, this is the cytoplasm, which is a solution. So anyway, we've zoomed in, we're just thinking about osmosis, which is the movement of water from a high water concentration to a low water concentration. You might see this referred to as the water potential. So a high water concentration equals high water potential. Right, so looking at our example here, which way is the water going to move? Is it going to go towards cell A or towards cell B? Right, which side has the most water on? We're going to go from the weaker solution towards the stronger solution. So water moves this way. Now, this you're going to see in one of a couple of different experiments. Experiment 1 is the potato osmosis experiment. The other one might be viscous tubing. And as a pupil, you'll be asked to predict, based on the concentration of the solutions, about which direction the water is going to move, how osmosis is going to affect things. So, if, for example, you get some potato cells, as you imagine, this is a close-up of our potato piece. Obviously these are plant cells, so they'd have a cell wall. You know, dun, dun, dun. That'll do. Give them a few mitochondria. Oops, that one's not got a nucleus, as we know. and the plants. So have a cell wall. Right. Let's put some water around these. Bom, 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 bom. Some water on the inside. Now, in here, we've got things dissolved. So let's say it's about a 6% solution on the inside. And here we've just got water. So it's a 0% solution. So if this water is going to move into these cells, the cells will expand. They'll get bigger. It's almost like blowing up a balloon. Okay. Now with the viscous tubing, what you end up with there is like a knot and a bag like this. Looks like a bit of a sausage. Viscous tubing is basically a semi-permeable membrane, and if that's a 10% solution in here and that's a 20% solution in here, which direction is the water going to move? Always trying to work out which has got the most water in. 20% solution, 2 bits of solvent for every 8 bits of water. 10% solution, 1 bit for every 10 bits, for every 9 bits of water. So the water is going to go out. So this will then shrivel up. It'll end up looking like final experiment you might be asked about is what happens if you put a semi-permeable membrane, and this is water, and we say, right, we've got five, 6, 7, 8, 9, 10% solution that way, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you may be asked, what's going to happen to the water level on each side of this semi-permeable membrane? Well, remember this, water moves that way. In this case, the water moves that way. Well, if you're getting some water from here and you're putting it onto this side, what's going to happen? Well, the water on this side is going to go up, and the water on this side is going to go down. And there's a couple of reasons why that happens. One is just the movement of water and the fact that the solute can't get through the semi-permeable membrane, so the water on average moves that way, from the high concentration of water to the low concentration, the high water potential to the low water potential. But there's one more thing to consider that adds to this effect, and that's if we look really close up, what we actually see is that if we've got our water we've got our water, and we put something in it. Remember, the water could get through the gaps in our semi-permeable membrane. We add some solvent to it, slightly bigger. They're too big to get through our semi-permeable membrane. Yeah, so you could zoom right in. Boom. Gaps there, look. Big enough for that. Not big enough for that. Well, what happens is when the water goes through, when it goes into solution, it actually binds on. It has a bit of a relationship with our solute, and they come together. Well, combined, they're now too big, so the water can't actually get back. So as the water comes through this way, we've got water here, and it comes this way and binds onto here. It can't get back again. Can't get back again, it's too big. So when we're looking at these experiments, the water comes in, it binds on with the solvent, with the solute, and the water is the solvent. Water comes in, makes the cells expand, because we're going from high water concentration to low water concentration. Same here, we could work out which direction water is going to move. Remember, osmosis is just the movement of water. Just the movement of water. That's all we're worrying about. Just adding that in. The water level. You're always going to be asked about which direction the water moves in. So if you had 3 cells like this, you've got a 2% solution, a 5%, a 6%, 2% solution. Has it got more or less water? Think about our line again. Which one's got the most? So water is going to move from here to there and to there. It's also going to move from here into there until eventually all of them have the same concentration. So osmosis. The movement of water across a semi-permeable membrane, that's our cell membrane, from an area of high water concentration to an area of lower water concentration. I'm going to change that. Lower. It's always about higher to lower. And that is osmosis.